Hello everyone, I am Ankit Yadav, and today I am here to explain what happens when we navigate with the liquid galaxy, as the title suggests, from click to glow. So we will be seeing what is the architecture, what all the processes happening between when we click on our app, or basically when we try to navigate to the liquid galaxy using our joystick. So what all are the intermediate processes happening, and what is the process structure, and what is the coordination, and how the uh, each process is related to each other. So let's start. So first of all, we will be seeing the architecture. So basically the workflow. So as we can see in a visual, we can see that the user is using the app to navigate to the basic. We can consider it as a Flutter app to navigate to the Liquid Galaxy. So as we can see that user is basically clicking on the like button to start a virtual tour or a fly to button. Then there is a this is not like a hardware. This is basically to show the how each process and what is the sequence of the each process. So you can see that as the user clicks, the data moves to the uh, uh, our master. So the master does the offset calculation. So we in this we will be studying what all how the basically the master is adjusting the position of each master, and what all are the calculations for the camera angle, for the basically roll and pitch the master is doing, and all the calculations which will be provided to the slaves further, so that there will be a synchronization between the master and our slaves. Moving on, we see that there is a secure broadcast via SSH. So we will be seeing what is a broadcast, and due to this only the data which will be called a view sync is reaching to each of the slaves. And then we can see that slave are like rendering the information from the network, and how the slaves are rendering the information from the server of the uh, basically Google Earth and the cesium all, and then finally how we are seeing the immersive view on our liquid galaxy. So we will be covering them all in a deep early manner, and then we will be uh, considering and try to join them, that how these all are connected to each other. So let's go. First of all is getting a input from a user. So capturing user intent. So as the focus suggests, the bridge between human and digital data. So these are like two input methodologies are mentioned here. Space navigator and touch interface. Space navigator we can consider like a joystick which provides us a 6 degree of freedom. Basically, we can go right, left, up, down, and right, left, up, down, inward, and forward. So yeah, these all are the 6 degree of freedom, and these all are will be provided by the user. So this is our first input methodology. Moving on, the second is a touch interface. So touch interface is basically, as the visual suggests, that we are touching. So we can consider that it is like a Flutter app. So we are touching a like start our tour, or fly to that specific location. So our user is providing the information as per the touch interface. So this basically here the KML controllers are like point of interest jumping. So let's move on and see the what happens in the input after input. So we can see that there is a translation layer. So when we are using analog physical movement like a joystick, so our that movement basically is instantly converted into KML, which is the language which is understood by the Earth, Google Earth. So the KML is a keyhole markup language. It is basically like a HTML. Like HTML is a like a skeleton while we are creating some website, or uh, any, like it is basically a skeleton or a blueprint. So similarly, we are the KML is a generic. language which is understood by the Google Earth. So the physical movement is instantly converted to the KML so that it can be understood properly by the Google Earth. The last point is data payload. So here we will be in a further also we will be seeing how the data is moving in a network. So here it is said that every millisecond the system generates the operation like locate and camera coordinate and the position and the orientation is being provided in every millisecond. So millisecond is basically in 1 second you are providing 60 times. So that is like very fast. So that is how the process of data payload is happening, which will be happening, which will be helping us during the process of broadcasting and rendering also. So let's move. And now we have the input from the user by whether it is by the physical movement, by the joystick basically, or by the touch interface, basically our Flutter based app. Now that information reached to the master. So now master is our brain of the Liquid Galaxy. We all know that. So the maths behind the seamless curve which we see in our uh, Liquid Galaxy is all done by the master. So in here we'll be studying the all the mathematics which was done by the master and so let's see. So we can see say that the master does not just display the center image. That master is not just to show the image on the center. It is basically to like connect. It is like to connect all the other slaves to itself. It calculates the perspective of the entire room. So entire room is basically all the slaves are connected to the master. So these now the specific, the very important in a work of our master is basically to offset the location of the each slave. Offset is basically our, as we know that like if we consider the five screen Liquid Galaxy setup, so we can say that our main screen, the master screen is at 0 degree. If we consider the specific coordinate which we have to look is on our master. So now master has to decide that what degree of angle that the user will see will be covered by the left side of the slave and the right side of the slave. So our master is doing all that calculation. So if the master is on the center, that is basically 0 degree in front of the user's eye. So the all the information like so the if we move to the left, then the angle will be given in a, as the you can see it is mentioned also. It is given a negative sign, and if we it is on the right, so then it will be negative because if zero to the left, it is basically negative. Zero to the right, it will be positive. So the left slave, we are considering a five screen Liquid Galaxy setup. So the master is making the connected left will be like getting a 20, minus 20 degree, and a left most will be getting minus 40 degree. So there is a 20-20 gap which will be creating a user view in a left peripheral vision. And similarly, in a positive, the right direction, the right connected slave will be getting a plus 20, and the right most will be getting a plus 40 degree. So by that are all the we are feeling like a wrapped up in the Liquid Galaxy. So these all offset calculation is being done by the master. Uh, Now, if we see or some other calculations, so basically when we are like making our camera preferences to the like handling the pitch and the roll. So basically the if screen are like tilted upward or downward, like if we see the cockpit style view, so the master adjusts the vertical angle so that the horizon remain level across the curve. So these all are the info calculations which are done by the master before sending the data to the network or before broadcasting the data into the network so that each slave can know their role. So these all are the like if the master is not there, the slaves will not be getting the what to show on them. So as a result, the mathematical perfection we can see so that all our slaves are perfectly synchronized and coordinating with our master. So now let's move on and see the broadcasting, how the broadcasting is happening. Okay. Yeah. So now see the broadcasting. So broadcasting is basically there's a two terms which comes when we see the broadcasting. There is a TCP and UDP. So in the Liquid Galaxy, we are using UDP because it has some advantage. So if we consider that why we are not using the TCP. So TCP is basically if any if at any information is being missing in between the transfer between one point to another, so then we have to resend the last data, which causes the like stutter and all the processes be like being not there will be error. There will not be a smoothness between the two processes, and that is why where the we use the UDP. It gives us advantage because our master is as we have considered seen this in the first slide also that there is like time in every 1 second there is the data is being transferred like 60 times a second. So that is like every millisecond our information is blasting in a network. So UDP consider that as an advantage because it takes that if any point, if any location, basically if any information is gone missing, so it will just wait for a millisecond and get that information and move forward. So there will not be that much delay, and there will be like smoothness between this process. So as the focus also says, the speed over perfection view sync. So view sync is basically the thread of information which is traveling between one point to another in the network. We will be seeing this in a further slide also. Now let's see the broadcasting loop. So now master has done its all calculation and it's done with all the offset of all the slaves and all the coordinate and all the information is being bundled by the master. So as we can see in a visual, the master PC, basically master screen, packages the coordinate and offset, then it blasts sent via dedicated gigabyte LAN to all slave IP address simultaneously. So to the all the slaves, the package is being forwarded via gigabit LAN to all the slaves IP address, and due to which then we after that we will the slaves confirms with the master that all the frame like as we can see frame check and sync is being checked by the slaves that all the processes are happening in a synchronized way or not. So these all are the part of broadcasting loop. So these broadcasting and blasts are happening like as we have seen also that in a 1 second these all are happening like 60 times. So every millisecond this whole loop is being repeating. Now let's move on and see, yeah, rendering. So rendering is the process which is done by the slaves only. Master screen is not doing this rendering process because master is doing all the calculations related to the offset, sync, and the camera angles. So rendering is basically it is done by each slaves individually. Like as the point also said that individual execution happens. So each slave PC is standalone powerhouse. They don't share a video signal. They each run their own instance of rendering engine. So basically they individually get connect to the server and get the data. Basically the server can be the Google Earth, Cesium, etc. So now the data is been fetched by the uh, slaves. Now slaves take the flat images. Basically, they pick up the satellite images which are basically flat. So now it converts it into the 3D terrain kind of a thing. So 3D terrain is being made so that we can visualize it in a 3D way. So 3D terrain is made, which is basically a uh, that is basically called a texture mapping when the uh, flat images of satellite is been converted into 3D. So slaves only render what is the specific 40 degree slice maximum frame rate. So this is basically the GPU lifting from from the server to the these are after reaching from the server the information, then the this texture mapping is being done. So as a final output, as we reach the 3D terrain, so now that 3D terrain has been converted to the uh, 2D grid colored grid format, colored grid pixels basically. So that is what we see on our screen, because our screen is basically 2D. So we cannot see the 3D. So that 3D is converted to the 2D so that we can visualize the 3D. So this is the rendering process which is done by the slaves only. Master is doing all the calculation, so the master does not involves in a rendering process. Now let's understand what powers the visual, that how the slaves are getting those, like what are the servers basically. So we can say the first is Google Earth, the industry standard for satellite and 3D building coverage. So yeah, Google Earth is basically a industry which is standard for satellite and 3D building coverage, from where our slaves can get the 3D basically the flat images of satellite, which are then converted to the 3D terrain with the help of texture mapping. Similarly, there is a cesium, which is an open source WebGL based alternative for custom GIS data. So yeah, Google Maps, all related data can also be covered by the cesium, and there are like any custom supports also, like support from Unity 3D, panoramic video player, and interactive webs basically. So these all are the responsible from where our slaves are rendering the information. So slaves uh, uh, gets the data from these all. Now let's move on. Now, if we try to connect the all the information, so as we can see in a visual, the intent is been taken by the user, basically a joystick or a Flutter-based app. Then our master PC does the calculation related to the so the data from joystick moves to the first. It will be going to the master. Then master will be doing all the calculation, basically where what angle of view the most and the left screen will be covering, what angle of view the right and the rightmost screen will be covering, and what will be the angle of basically the view, what is the camera preferences, and these are being bundled by the master. And as we can see, then moving forward, the broadcast. So now the master will make a view sync, basically a bundled information of what will be the offset and what will be the coordinate you will be showing. So these all will be bundled by the master, and the master will be moving that, basically broadcasting, that is our next. So broadcasting is basically blasting your data in the network so that it can be reached to the each of the uh, 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 slave using the SSH connection. So as the data is being bundled and then moved in a network, so then it will be sent to the slaves I specific, so that this will be your angle, and so that each slave can understand what they have to show. And finally, the slaves does the rendering. The slaves renders the information from the master also, and from the upper servers also, so that it can then do all the processes which basically creates the 3D visual in on our 2D surface. So basically all the data is taken, and then they are so the rendering is being done by the individually, so they get the data, they will be get the flat data, then they will be converting it to the 3D, that is basically our texture mapping. Then after texture mapping, they will be checking the camera preferences, which will they will be receiving from the master, which is broadcasting by the master in the network. And moving on, they will be saying the light shade is basically what is the position of a sun, and what all are the parameters of the view. and the last the 3D is converted into the 2D grid uh, pixels, colored pixel, so that we can visualize the uh, uh, 3D information on our 2D setups. So yeah, thank you for your time, and thank you for to Liquid Galaxy to give me an opportunity to explain these topics.